These are notes for section 7.5, factoring trinomials. And we need to remember that factoring, as it says here, factoring is the undoing of multiplying. In the previous section, 7.4, we introduced factoring using a GCF. A quick example will help us see that factoring is simply the undoing of multiplying. For example, if you had 2x parentheses 3x minus 4, I could get rid of these parentheses by distributing. That is multiplying. 2 times 3 is 6x squared, and 2x times 4 would be minus 8x. Well, that is putting it together. That is multiplying. What we are doing now is the opposite. We're going the other direction. We are factoring. So what we should ask ourselves is, what time or what number will go into 6 that also goes into 8? Well, that would be 2. The GCF between x squared and x would be 2x. Now I need to work backwards. What times 2x is 6x squared? Would that be 3x? 2 times 3 is 6. X times x is x squared. Minus, because it's a minus sign. And what times 2 would give me 8? That'd be minus 4. And you can see that this 2x parentheses 3x minus 4 is exactly what we started with up here. It's the exact same thing. One of them we're multiplying and putting it together. The other one we're factoring and pulling it apart. So if we keep that in mind, that will help us understand the problems for the rest of the chapter in chapter 7. So to help us figure out how to factor more complicated quadratics, we can simply look at what happens when we put some of these things together. For example, if I have these two sets of parentheses, I know that I can multiply. So x times x is x squared, x times 2 is 2x, 9 times x is 9x, and 9 times 2 is 18. After we multiply through, I can combine like terms. That's plus 11x plus 18. So let's put all of these together, and then we'll talk about what we have in these quadratic polynomials. X times x is x squared. X times negative 1 is minus x. Negative 3 times x is minus 3x. And negative 3 times negative 1 is positive 3. Combine like terms, x squared minus 4x plus 3. And on the last one here, that's x times x is x squared. X times 5 is 5x. Take the 4 and run it through. That's plus 4x plus 20. Sorry, I ran out of room there. That's x squared plus 9x plus 20. Again, that's something that we should be familiar with. That was covered in section 7.1 through 7.3. What we're interested in is looking to see if we can find a pattern happening in all of these answers and how they relate back up to the problem that we're given. Because what we're trying to do is not multiply, but what we're trying to do is get from our answer here back to its factored form. What we're trying to do is take this that was multiplied and pull it back apart to end up here. So can we take this that was multiplied and end up back here where in its factored form? And what I'm saying is here we multiplied to end up with our answer, and we could factor to end up back here. So let's take a look at these parentheses. How could I combine a 9 and 2 and make it into an 11? I could add them. 9 plus 2 is 11. How could I combine 9 and 2 to make it into an 18? Well, I can multiply. 9 times 2 is 18. So 9, I don't want to erase. 9 plus 2 is 11. And 9 times 2 is 18. And that pattern will hold true here. If we look, negative 3 minus 1 is negative 4. Negative 3 times negative 1 is positive 3. 4 plus 5 is 9. 4 plus 5 is 9. 4 times 5 gives me 20. So these numbers in the parentheses are what is leading me to my answer, and it's multiplied quadratic polynomial. And we use this pattern to help us pull apart these factors. And if all of that went over your head, I have some steps here for us. In order to factor, what we have to do is first make two sets of parentheses, and I can put an x and an x in each spot because I know x times x is x squared. And here's the number game that we have to play. I have to find factors or numbers of C. So I need to find numbers that multiply to C, multiply to C, and add to B. Multiply to C and add to B. So let's come back up here to these examples. So numbers that multiply, maybe I can pick a different color here. Let's clean some of this up. Got too much going on. There we go. 11x. So numbers that multiply to 18 and add to 11. Multiply to 18 and add to 11. 9 times 2, 9 plus 2. Numbers that multiply to 3 and add to 4. Numbers that multiply to 20, 5 times 4, 5 times 4 is 20, and add to 9. 5 plus 4 is 9. So we use these factors to figure out what our combination of numbers is. Of course, we need to make sure that we have the correct signs and then fill in our parentheses. So let me walk through a couple of examples here. On number 1, I know that if I make two sets of parentheses and I put an x in each first spot here, x times x will be x squared. Now what I'm doing is I'm looking at the last number in the polynomial, 12. And I'm writing down all of the numbers that multiply to 12. 1 times 12, 2 times 6, 3 times 4. These are the combinations that multiply to give you 12. One of these, either 1 and 12, 2 and 6, 3 and 4, one of those combinations is my answer. So the combination is whatever of these numbers multiply to 12 and add to 7. Well, that doesn't add to 7. That doesn't add to 7. It's 3 and 4. 3 and 4. And that has to be a positive 3 and a positive 4 because it must add to a positive 7. So numbers that multiply to 12, 3 times 4, and add to 7, 3 plus 4. So this is the factored form of the trinomial. We've pulled the quadratic and made it into its two linear pieces. On number 2, x and x will get me x squared. And I'm looking for numbers that multiply to 5, and add to 6. So that'd be 1 times 5. Those are the only numbers that multiply to 5, 1 times 5. So it must be 5 times 1 or 1 times 5. The order of the numbers does not matter. And since it's a negative 6, they both have to be negative. On number 3, x and x will get me x squared. And again, I'm looking for numbers that multiply to 5 and add to 6. Multiply to 5 and add to 6. 1 and 5. Again, it's the same combination, 1 and 5. But now I need it to make a positive 6, so they're both positive. Same sign, add and keep. They both must be positive. On number 4, x and x will get me x squared. I'm looking for numbers that multiply to 24 and add to 10. Numbers that multiply to 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. All of these multiply to 24. Only one of these combinations will add to 10. Well, that would be 4 and 6. Minus 4 and minus 6. It's a simple numbers game, and we can play this numbers game based on how these things get put together. When we distributed these out, we ended up with those polynomials. And there's a pattern that takes place. Numbers that multiply to C and add to B. Last two. On number 5, X and X will give me X squared. I'm looking for numbers that multiply to 18 and add to 9. So numbers that multiply to 18. 1 times 18, 2 times 9, and 3 times 6. Which of these combinations will add to 9? Well, that's positive 3 and positive 6. And on the last one, X and X will give me X squared. I'm looking for numbers that multiply to 6 and add to 5. That's 1 times 6 or 2 times 3. Well, 2 times 3 will add to 5. So it's minus 2 and minus 3. And again, a quick talk about how to figure out what the signs are. Whatever the sign is in the middle, that's the sign of both the numbers. Because if they're going to add, they have to be the same sign. Same sign, add and keep. So it's minus 2 minus 3 or plus 3 plus 6 over here on number 5. Hopefully that helps. See you on the next one. Thanks.